our students when we are asking, when we are discussing, when we are interacting with the many of the students. So if I ask, when I am asking what is meaning of a continuity, so no, many of them not telling the proper definition of the continuity. So they always used to tell a function is continuous when left hand limit is equal to right hand limit and is equal to that what the value of the function at some x is equal to a. So many of the students are telling the same things. So but actually the what is meaning of when you say a function is continuous at some point x is equal to a is actually this is the definition. So a function f of x is said to be continuous at x is equal to a. So for a small value, some epsilon, you take that small value as some epsilon greater than 0, then there exists a real number, another real number that is also is a very small quantity, that is delta. You take it is delta greater than 0, such that when the mod of f of x minus f of a, when this difference is very small, definitely x minus a difference is also very small. So then we say the function is continuous. So actually the meaning is it is very simple. So the function doesn't takes any breaks or any jumps at that point x is equal to a. Suppose it takes some jumps or some breaks, that function is function means usually we consider that function means it is a curve. The curve is not taking any breaks. So then we say it is a continuous curve. Otherwise it is not continuous curve. So, okay, it is clear from the above definition that, okay, it is a continuous one. It does not takes any breaks, jumps. So then definitely f of x exits at x is equal to a. So that means f of a exits. And limit of f of a, x, when x tends to a is the same as f of a. When the limit of f of x when x tends to a is same as f of a. Okay, so some intervals. Suppose if you take one real interval like 1, 2, 4, 5, like that, you take any real interval. In that interval, a function is continuous. We say that the function is continuous in the interval. So if it is continuous at all the points, okay. So before going to that, you should know that what is an open interval and closed interval. So what is meaning of an open interval? So when x is the value, it is in between a and b. It excludes a and b. So that means except a and b, it includes all the values in between a and b. So that can be written by using a common bracket like this. Okay. So then we say that function is so this is called the open interval. Open interval. Similarly, when x takes the value between a and b as well as a and b, it includes a and b, it takes all the values in between a and b. So that in that time, that interval can be written by using a square bracket like this. So this is called a closed interval. In closed interval means it includes all the values in between a and b along with a and b. But in open interval, it includes all the values in between a and b except a and b. So that is the difference. So ab ನಲ್ಲಿ ab ಬಿಟ್ಟು ಬೇರೆ ಎಲ್ಲ ವ್ಯಾಲ್ಯೂಸ್ ಇದ್ರೆ ಅದು ಓಪನ್ ಇಂಟರ್ವಲ್. ಸೊ ab ನ ಸೇರಿಸಿಕೊಂಡು ಎಲ್ಲ ವ್ಯಾಲ್ಯೂಸ್ ಇದ್ರೆ ಅದು ಕ್ಲೋಸ್ಡ್ ಇಂಟರ್ವಲ್ ಆಗುತ್ತೆ. ಸೊ ಒಂದು ಕ್ಲೋಸ್ಡ್ ಇಂಟರ್ವಲ್ ಅಲ್ಲಿ ಕಂಟಿನ್ಯೂಸ್, ಸೊ ಫಂಕ್ಷನ್ ಇಸ್ ಸೆಡ್ ಟು ಬಿ continuous in the interval. So when it is continuous at all the points, now ಹೇಳ್ತಾ ಇರೋದು, so we are discussing the continuity at one point. So the function is continuous at all the points in the interval. Then we say the function is continuous in the interval. Similarly, what is meaning of discontinuous function? A function is discontinuous. So when it is not continuous, then it is a discontinuous. For example, you see this figure. That figure 1 gives that it is a continuous one. So no jumps, breaks. It not takes any breaks. Okay, it is a continuous function. And second one, this is not continuous function. So after this straight line takes break and again the curve is continuing like this, means it is not a continuous function. Just an example I am given. Okay. So discontinuous function is one which is not continuous. Similarly, differentiability is many of the times you are taking differentiation of a functions. But actually, what is meaning of differentiability? When you say a function is differentiable at some point, a function is said to be differentiable at some point, say some a function is differentiable at a, so when it exits one limit. What that limit? So it exits this limit. What is that? So it is that the function is differentiable at some point x naught, so it must exit this limit, that is limit of f of x minus f of x naught by x minus x naught when x extends to x naught, where x naught is a point in domain D. So that is in that domain is the subset of real numbers. So that is a subset of real numbers. So if this limit exists, so then we say the function is differentiable. So for that reason, when you are solving differentiability problem, we are taking left hand derivative, right hand derivative like that. That both matches. Then we say that function is differentiable. Actually, geometrically, what is the meaning of differentiability? Or when you say the function is differentiable, you see this f of x minus f of x naught by x minus x naught. So when you take a curve and actually what this point is in a curve. So just I try to draw that here. Is let us take one curve here. X is any point. So then this is the point x when curve is f of x. So this is f of x, f of x, and this is the point with coordinates line. This straight line is m x1. Similarly, if you take the slope of this line joining these 2 points, it is nothing but that means what? So f of x minus f of x naught by x minus x naught give the slope of this straight line. So what is the if you take the limit for this means that is x tends to x naught means as x is when x is moving towards x naught, this line is goes on decreasing and ultimately it merges at this point, but it is not x is equal to x naught. The x naught is x is just moving towards x naught, that's it. Okay, so that means what actually it gives, definitely this is the value which gives the slope of this curve at this point, so how, suppose if I wanted to calculate the slope at this point, so then how can I calculate the slope? So if I wanted to calculate the slope at this point, better you take the tangent at this point. Okay, so the tangent gives the slope of the curve at that point x naught. The tangent of the slope is same as the slope of the curve at x naught. So if you draw a tangent at x naught, so that tangent slope is same as the slope of the curve at x naught. Slope of the curve at x naught. Okay, so actually what is this mean? So when you are taking this f of x minus f of x naught by x minus x naught when x tends to x naught gives the slope of the curve at some point x naught. So if that slope exists, so that means we can this value exists means the slope of the curve exists at this point. So when the slope, when we can calculate the slope, when it is possible to draw a tangent at this point, then in that time we can calculate the slope. If it is not possible to draw a tangent, it is not possible to calculate The slope at that point, it is not possible to draw a tangent means the curve is in the form such that it is not differentiable. Then we say then we say that function is that the curve is not differentiable at some point x naught. Okay, generally you should understand that the function is differentiable means, so if a differentiable curve or smooth curve means we can draw a tangent at that point. It is differentiable at some point x naught means at the x naught we can draw a tangent. The curve is smooth at this point. So you see this a sinusoidal wave is I am drawn here. So it is definitely a differentiable curve. Suppose a curve is like this. So just I draw this curve. Okay. So it is not differentiable at some point here. If you take mod x, y is equal to mod x. Y is equal to mod x is the curve like this equal to 0. Origin it is not differentiable. Why? Because it is not possible to draw a tangent. Why it is not possible? Tangent means what? Is it is line segment, it touches the curve at one point. So it is not possible to draw a tangent at one at this point means, so the function is not differentiable. You go and verify mod x. Why is if by taking f of x is equal to mod x, you check left hand derivative, right hand derivative, both are different. Many times we discussed. So when you are talking about the differentiability concepts in previous semesters, okay. So you just understand that a function is differentiable means we can draw a tangent at all the points. Suppose a function is differentiable in the interval. In that interval, we can draw a tangent at all the points. So at all the points, we can find the slope. Okay. So then we say that curve is smooth or differentiable. Okay, so that is f dash of x naught. We denote this value is f dash of x naught. F dash of x naught is equal to f of x minus f of x naught by x minus x naught. Right. Yes, based on this, so this is the, so just recapitulation of previous concepts to understand some important theorems on calculus. So one of the important theorem in calculus is Rolle's theorem. Rolle's theorem, ROLLES, both are same, you can write it. So what this Rolle's theorem states? So this is the statement. A Rolle's theorem states that if f of x is a function defined on AB, so defined on the interval AB such that f of x is continuous on AB, it is a continuous function in the interval AB, closed interval, and f of x is differentiable on AB. That means it is an open interval we are using. Okay. So next, f of A is equal to f of B. When it satisfies this condition, f of A is equal to f of B, then definitely there exists at least one value x is equal to c, where that c is in between ab, c is the value, it is in between ab, for which at that point f dash of c is equal to 0, the derivative of the function is equal to 0. Is to understand this theorem, uh, we should first we should know that what is the continuity and the differentiability of the function some point. Okay, to prove this theorem, so let us take that a function f of x is continuous. Is in statement itself they say that the function is continuous in the interval AB. You see, we discussed one theorem. If f of x is a function continuous in the closed interval AB, then definitely it is bounded. So that means it has one upper bound and one lower bound. And after that it attains its bounds at least once. It attains its bounds at least once. You know its meaning. So when f of x is a function, so what is meaning of a bounded function? So for example, if f of x is equal to, just written here, if f of x is equal to 2, Yes, we say that this is a bounded function. This is bounded function. So that means it exists one upper bound and one lower bound. What is the upper bound and lower bound of this function? So upper bound of this function is 4, lower bound is 1. So not only 4, you can take the upper bound is 5 also. Upper bound is 5. 6 also the upper bound. If you wanted to say 5 is the upper bound of this function, all the values of the function in the interval 1 to 2 must be less than that value 5. Yes, according to our definition, is it is satisfying the 5 is satisfying the condition. So we can take that 5 is the upper bound. So upper bound should not be the value of the function. Alli function ಒಳಗಡೆ ಇರೋ value ನ ಆಗಬೇಕು ಅಂತ ಏನಿಲ್ಲ. You can take 100 also the upper bound, 1000 also the upper bound. So among all these upper bounds, the least upper bound is 4. The least upper bound. It is also called supremum. Supremum. Supremum of this function is 4, and lower bounds of this function is 1, 0, -1. All are lower bounds. So the greatest lower bound is 1. Greatest lower bound is 1. So it is also called infimum. Infimum. So when the function is bounded, suppose when the function is bounded in the closed interval AB, so then it attains its bounds. We in previous semesters we proved this theorem. So it attains its bounds means for at least one of the value in between 1 and 2, by substituting that value to the x, we obtain a supremum and infimum. So ಆ 1 2 ಮಧ್ಯದಲ್ಲಿರೋ ಯಾವುದೋ ಒಂದು ವ್ಯಾಲ್ಯೂನ ಸಬ್ಸ್ಟಿಟ್ಯೂಟ್ ಮಾಡಿದ್ರೆ x ಗೆ, ಒಂದು ವ್ಯಾಲ್ಯೂಗೆ ಸುಪ್ರೀಮಮ್, ಇನ್ನೊಂದು ವ್ಯಾಲ್ಯೂಗೆ ಇನ್ಫಿಮಮ್ ಬಂದೇ ಬರುತ್ತೆ. ಎಸ್, ಇಲ್ಲಿ ಬರ್ತಾ ಇದೆ ನಮಗೆ 1 ಕೊಟ್ರೆ x ಗೆ ಇನ್ಫಿಮಮ್ ಬರ್ತಾ ಇದೆ, 2 ಕೊಟ್ರೆ x ಗೆ ಸುಪ್ರೀಮಮ್ ಬರ್ತಾ ಇದೆ. So then we say that function attains its bounds at least once for some value in between AB. When you are substituting that value, it gives the supremum, and for another one value it gives the infimum. Yes, we take that same conditions here. Yes, let C and D be the points in AB, the values in between AB. So when we are substituting C, we are getting supremum. When we are substituting D for x in place of x, we are getting infimum. So don't think that the boundary points becomes the supremum and infimum, because suppose the function for the function f of x is defined in between -1 to +1. Don't think that by giving -1 to the x we are getting infimum. No, by giving -1 we can't get the infimum value. ನಮ್ಗೆ ಇನ್ಫಿಮಮ್ ಬರಬೇಕು ಅಂದ್ರೆ ಇಲ್ಲಿ 0 ಕೊಡಬೇಕಾಗುತ್ತೆ, -1 ಕೊಟ್ರೆ ಬರಲ್ಲ ಇಲ್ಲಿ. ಸೊ ಸಮ್ ವ್ಯಾಲ್ಯೂ ದಟ್ ಇಸ್ ಇನ್ ಬಿಟ್ವೀನ್ ಎ ಬಿ ಮಧ್ಯದಲ್ಲಿರೋ ಯಾವುದೋ ಒಂದು ವ್ಯಾಲ್ಯೂನ ಕೊಟ್ಟಾಗ ನಮ್ಗೆ ಸುಪ್ರೀಮಮ್ ಬರುತ್ತೆ, ಇನ್ಫಿಮಮ್ ಬಂದೇ ಬರುತ್ತೆ. ಸೊ ದಿಸ್ ಇಸ್ ಪಾಸಿಬಲ್ ಓನ್ಲಿ ವೆನ್ ದ ಫಂಕ್ಷನ್ ಇಸ್ ಕಂಟಿನ್ಯೂಸ್ ಇನ್ ದ ಕ್ಲೋಸ್ಡ್ ಇಂಟರ್ವಲ್ ಎ ಬಿ. ಓಕೆ. Yes, when we are given C in place of x to the function f of x, it gives the supremum, and when you are substituting D in place of x in function f of x, it gives the infimum. So m and m are the infimum and supremum of the function. So here we have two possibilities. One is either m is equal to m, supremum is equal to infimum. So that supremum may not be is equal to infimum. So that is possible. In some cases supremum is equal to infimum. In some cases supremum and infimum are different. Okay. Yes, in first case you think that supremum and infimum are one another the same. So okay. So when it is possible the supremum and infimum of the functions are same, it is possible only when the function is constant function. This is possible only when the function is constant function. For example, f of x is equal to 5. You take the function f of x is equal to 5. What is the supremum? 5. What is the infimum? 5. Supremum is 5, infimum also 5. So because it is a constant function, so when it is supremum and infimum same means it is possible only in a constant functions. So f of x is constant, then what is its derivative? Its derivative is 0 because it is a constant function. Derivative of a constant function is 0. So f dash of x is equal to 0 for any value in between ab. ab ಮಧ್ಯದಲ್ಲಿರೋ ಯಾವುದೋ ವ್ಯಾಲ್ಯೂ ನ ಹಾಕಿದ್ರೆ ಎಲ್ಲದಕ್ಕೂ 0 ಆಗುತ್ತೆ. ಓಕೆ, ಸೊ c ಹಾಕಿದ್ರೆ c ಗೂ 0 ಆಗುತ್ತೆ. So when you are substituting x is equal to c, for that value also f dash of x is 0, that is f dash of c is equal to 0. So our intention to prove that f dash of c is equal to 0 is we have proved the same thing in case 1. So in case 2 also you consider, in case 2, what is the case 2? When supremum and infimum are different. When the supremum and infimum are different, says by taking that supremum is not equal to infimum, then one of the value will be different from f of a and f of b. One of the value will be different from is when supremum and infimum are different, then definitely that supremum and infimum, when supremum and infimum are different, so then f of, so this supremum and infimum is different from f of a and f of b. At least one of that is different from f of a and f of b. So what is its meaning? You see, what I just consider the example which is given in the last page. 1 minute, I will show. Is the f of x, yes, you observe here, f of x is equal to x square in 1, 2. Yes, to obtain the supremum, I am given x is equal to 2. When you are putting x is equal to 2, f of 2 is equal to 2 square, 2 square is equal to 4, 4 is the supremum of this function. And to obtain infimum, I am given this value 1. So when you are given x is equal to 1, it gives the infimum. Suppose you consider the interval is minus 1 and 1. To the value 1, it gives the supremum. When x is 0, it gives the infimum. When x is 0, it gives the infimum. So don't think that when we are given the boundary points, for one boundary point it gives the infimum and one boundary point it gives the supremum. Boundary points ಹಾಕಿದ ಮಾತ್ರಕ್ಕೆ supremum infimum ಬರೋದಿಲ್ಲ. ಆದ್ರೆ ಒಂದು ಬೌಂಡೆಡ್ ಫಂಕ್ಷನ್ ಆಗಿದ್ರೆ ಇದು, ಸೊ ಈ ಕ್ಲೋಸ್ಡ್ ಇಂಟರ್ವಲ್ ಅಲ್ಲಿ ಡಿಫೈನ್ ಆಗಿದ್ರೆ, ಸೊ ಇದು ಬೌಂಡೆಡ್ ಫಂಕ್ಷನ್ ಆಗಿದ್ರೆ ಡೆಫಿನೆಟ್ಲಿ either supremum or infimum is obtained by any of this boundary point. ಇದರಲ್ಲಿ ಇರೋದು ಒಂದು ಕೊಟ್ಟಾಗ ಒಂದು supremum ಬರುತ್ತೆ, ಇಲ್ಲ ಅಂದ್ರೆ infimum ಬಂದೇ ಬರುತ್ತೆ. Okay, so that same concept is taken here. When supremum and infimum are not same, then one of them will be different from f of a and f of b. Either f of a is not equal to m or f of a is not equal to small m. So either f, so that f of m, so one of them will be different from f of a and f of b. Okay, so ಮುಂದೆ ಗೊತ್ತಾಗುತ್ತೆ. Let m supremum m is equal to f of c. We don't know, so ನಾ ಅವಾಗಲೇ ಹೇಳಿದ ಹಾಗೆ ನಾನು, so when I am explained in last page that, so we obtains either supremum or infimum to the boundary values. So that is a ಅಥವಾ b ಯಾವ್ದಾರ ಒಂದು ವ್ಯಾಲ್ಯೂ ಕೊಟ್ಟಾಗ supremum ಅಥವಾ infimum ಬರುತ್ತೆ. ಸೊ ಯಾವುದೋ ಒಂದು ಡಿಫರೆಂಟ್ ಆಗಿದೆ ಅಂತ ಇಟ್ಕೊಂಡು, ಲೆಟ್ m is equal to f of c, that supremum is equal to f of c, that be different from f of a and f of b. ಅದು f of a ಗೆ ಮತ್ತೆ f of b ಗಿಂತ ಡಿಫರೆಂಟ್ ಇದೆ ಅಂತ ಅನ್ಕೋಬೇಡ. ಸೊ ಜಸ್ಟ್ ಇಮ್ಯಾಜಿನ್ ಮಾಡ್ಕೊಳ್ತಾ ಇದೀವಿ. ಸೊ ದಿಸ್ f of c is different from f of a and f of b. That means m is not equal to f of a and m is not equal to f of b. So when a less than c less than b. Yes, since f of c is the what is means, so what is this f of c is? F of c is the supremum, the greatest value of the function. So this is the highest value of the function. So remaining values are less than this one. So f of c is the highest value. So when you taken f of x minus f of c is the highest value. So definitely this value gives f of x minus f of c gives a negative value. So it should be less than or is equal to 0. So when it is negative, so then what about this one? F of x minus f of c by x minus c. It is negative or positive. So this quantity is negative only when this denominator is positive, because that numerator is already negative. ಇದು ಟೋಟಲ್ ನೆಗೆಟಿವ್ ಆಗಬೇಕು ಅಂದ್ರೆ ಡಿನಾಮಿನೇಟರ್ ಪಾಸಿಟಿವ್ ಆಗಬೇಕು. ಇದು ಆಲ್ರೆಡಿ ನ್ಯೂಮರೇಟರ್ ನೆಗೆಟಿವ್ ಆಗಿದೆ. ಓಕೆ, ಸೊ ದ ಡಿನಾಮಿನೇಟರ್ is positive when denominator is positive, total this quantity becomes negative. So for that reason you take this is negative when the denominator x minus is positive. You take this is the equation 1. Similarly, this numerator is already negative. So this total quantity is positive and denominator becomes negative. So by taking the denominator is negative, that is x minus is less than 0, you take this is the quantity greater than 0. So as f of x is differentiable, so in the statement itself they are given that f of x is a differentiable function. It is differentiable in the interval a b. So it is differentiable at all the points in between a b. C is the value, it is in between a b. So it is definitely differentiable at c also. So when it is differentiable at c, then it must exist this limit. C ನಲ್ಲಿ differentiable ಆಗಬೇಕು ಅಂದ್ರೆ ಈ ಲಿಮಿಟ್ ಎಕ್ಸಿಸ್ಟ್ ಆಗಿ ಮಾಡಬೇಕು. ಯಾವುದು ಲಿಮಿಟ್? ಲಿಮಿಟ್ ಆಫ್ f of x minus f of c by x minus c when x tends to c, that exists. So and what this quantity is either negative or positive. So this quantity or this value is negative when x minus c is greater than 0 according to equation 1. And this quantity is that f dash of c is positive when x minus c is less than 0. So it is positive when x minus c greater than 0. It is when it is negative when x minus c greater than 0. It is positive when x minus c less than 0. So the differential value, that means it is less than 0 when it is greater than 0. It is when x minus is less than 0. So for this condition, when x greater than c, when x less than c, when x greater than c means what you consider that right hand derivative, that left hand derivative. So you see this is f dash of c is the value is less than 0 sometimes and it is greater than 0 for some values. So what is x? We don't know. X is positive or negative. X is the any value in between a b. c ಅಂದ್ರೆ ಯಾವುದೊಂದು ಫಿಕ್ಸ್ಡ್ ವ್ಯಾಲ್ಯೂ ತಗೊಂಡಿದ್ದೀವಿ. x ಏನಾಗಿರುತ್ತೆ? x c ನ ಎರಡೂ ಕಡೆ ನೀವು ಬೇಕಾದ್ರೆ ತಗೋಬಹುದು. So you can choose x is the value in the interval. ಯಾವುದಾದ್ರೂ ವ್ಯಾಲ್ಯೂನ ಎಲ್ಲಿ ಬೇಕಾದ್ರೂ ಚೂಸ್ ಮಾಡ್ಬೋದು. So suppose this is the interval ab. This is the interval AB. C is any value in between AB. C is any value in between AB. Suppose x means what? X you can choose anywhere in between AB. So suppose when x is here, C is the x minus C is greater than x. Suppose when x is here, so C is less than x. But wherever you choose the x, without x has no restrictions. Wherever you choose the x, it must give the same value for f dash of C. But so in one case it is negative, one case it is positive. So it is negative as well as positive means, so it is possible only when that f dash of c is equal to 0. So ಒಂದು ನೆಗೆಟಿವ್ ಮತ್ತೆ ಪಾಸಿಟಿವ್ ವ್ಯಾಲ್ಯೂ ಎರಡು ಈಕ್ವಲ್ ಇರೋದು ಯಾವಾಗ ಅಂದ್ರೆ ಅದು 0 ಇದ್ದಾಗ. So this is possible only when f dash of c is equal to 0. So we conclude that so f dash of c is 0 in the case when m is equal to f of c. So similarly, you take that small m is equal to f of c is different from f of a and f of b, and we arrive the same result, that is f dash of c. So in both the cases, we have that f dash of c is equal to 0. So this is what that Lagrange's Rolle's theorem. This is the statement of Rolle's theorem. Okay. It is asking this. Okay, geometrically, what this Rolle's theorem states that is what actually that Rolle's theorem is. Mm, okay, yes, delete this. Okay, geometrically, what is the Rolle's theorem states? So Rolle's theorem states that, let us take one curve here. So Rolle's theorem states that if you consider a curve and it is defined in between A, B. Yes, you consider a car, it is defined in between A, B. Sir, I'm not written properly. 1 minute. I'll delete this. Yes, let us. Sorry. Mm, so let us draw a car. This is y-axis and this is x-axis. This is the car. So and take 2 points A and this is B. So okay, now this is the car f of x. It is defined in between A and B. It is defined in between A and B. So it is the curve satisfying three conditions of Rolle's theorem. What is that Rolle's theorem? So f of x is continuous in AB. Yes, it is continuous in between AB. Nowhere it is discontinuous. Nowhere it takes jumps, breaks. Okay. So second condition of Rolle's theorem is it is derivable in AB. Yes, it is differentiable in AB. We can draw a tangent at all the points in between AB. No doubt in it. And third condition, f of a is equal to f of b. Yes, just to compare this side. F of a means this side. F of b means this side. So f of a and f of b are same. This is f of a and this is f of b. Both are same. So you can draw this point is a f of a. This is a b f of b. Okay. Yes, it satisfies all the conditions of Rolle's theorem. Then it must exist at least one point. At that point, f dash of c, the differentiation is 0. When you take the differentiation, what it gives? One function differentiation ಮಾಡಿದ್ರೆ ಏನು ಬರುತ್ತೆ ನಮಗೆ? Slope of the tangent ಬರುತ್ತೆ. So when the slope of the tangent is 0, slope of the tangent is 0 when the tangent is parallel to x-axis. So like this. So this is the tangent. This tangent parallel to x-axis. So at this point, if you draw a tangent to the car, so at this point, tangent tangent to the car is equal to the slope of the tangent to the curve is equal to 0. We obtain at least one such point when the curve satisfying all the three conditions of Rolle's theorem. Suppose a curve is like this. Tangent. So at this value becomes the c. When you draw a tangent at this point, the tangent is parallel to x-axis. That tangent parallel to x-axis. Draw a tangent. Yes, in this case we have two such points. So it may exist more than one such points. So 3 points are there. ಇಲ್ಲಿ 3 points ಇರುತ್ತೆ. ಬಟ್ ರೋಲ್ಸ್ ಥಿಯರಮ್ ಏನ್ ಹೇಳುತ್ತೆ, ಅಟ್ ಲೀಸ್ಟ್ ಒಂದು ಪಾಯಿಂಟ್ ನಮ್ಗೆ ಆ ತರದ್ದು ಸಿಕ್ಕೇ ಸಿಗುತ್ತೆ ಅಂತ ಹೇಳುತ್ತೆ. Okay, so like that. So this is some something about Rolle's theorem. Okay, so next coming days I am discussing Lagrange's mean value theorem and the problems on Rolle's theorem. So okay, I want to stop this now. Thank you.